Everyone, today in this session let's discuss about the advantages of threads, kernel level thread and user level thread, and what are their advantages and disadvantages. Coming to the advantages of threads, the first one we will say it is having low overhead. That is, when we are switching the CPU from one thread to another thread of the same process, then there is low overhead, whereas the resource state is switched only when we are switching between the threads of different process. So this is what we have said, low overhead. The second one we have is speed up, because this thread provides concurrency within a process. It can provide the computation speed up. That is, if one thread of a process blocks on an IO operation, the CPU can be switched to another thread of the same process. The third one we have is they can communicate or synchronize using shared memory, thereby eliminating expensive system calls. So these are the list what we have for the advantages of thread, that is low overhead, speed up and efficient communication. Next we have kernel level threads. This kernel level thread is implemented by the kernel. Therefore, the creation and termination of kernel level threads and checking their status is performed through operating system. When a process makes a create thread system call, the kernel assigns an ID to it and allocates a TCB, nothing but thread control blocks. Therefore, this TCB contains a pointer to the PCB of the process. So these are the pointers we have which are pointing to PCB, and for each thread we have thread control block TCB. These are the thread control block and these are the pointers we have from TCB to PCB. When an event occurs, the kernel will save the CPU state of the interrupted thread in its TCB, nothing but in its thread control block. After event handling, so this occurs when an event occurs. When an event occurs, the kernel will save the CPU state of the interrupted threads in its TCB. After that event is handled, the scheduler considers TCBs of all threads and selects one ready thread. So dispatcher uses the PCB pointer in its TCB to check if the selected thread belongs to a different process than the interrupted thread. If it is so, it saves the context of the process to which the interrupted thread belongs, and it loads the context of the process to which the selected thread belongs. It then dispatches the selected thread. So this is the overall scheduling of kernel level threads. So we have the processes PI and PJ. You can see the PI is having 3 threads and PJ is having 2 threads. For every thread we have TCBs, and a kernel has assigned an ID to this, and each TCB is having a pointer which is pointing to PCB. So for PJ also we are having 2 threads and it is also having thread control block. So when this context of the process to which the interrupt thread belongs and loading the context of the process to which the selected thread belongs, it is done, it then dispatches the selected thread. Therefore, the actions of saving and loading the process context are unnecessary if both the threads belongs to the same process. Coming to the advantages and disadvantages of this kernel level thread is, so this is a similarity is convenient for programmers. So programming for threads is not different from programming for processes. The second advantage is, in a multiprocessor system, the kernel level threads provides parallelism. That is, the threads belong to the many threads which are belong to the same process can be scheduled simultaneously, which is not possible in user level thread. Whereas the disadvantage is, switching between the threads is performed by the kernel as a result of event handling. Therefore, even the interrupted thread and selected thread belongs to the same process. That is the overhead because the kernel can switch only when there is an event handling. Therefore, this feature limits the savings in the thread switching overhead. Next level we have is user level threads. So these user level threads are implemented by a thread library which is linked to the code of a process. So here the kernel is not aware of the presence of user level thread in a process. It sees only the process. The scheduler, it is your process control block, right? So the scheduler considers PCBs and selects a ready process and dispatches. Then the dispatcher will dispatches it. So here most of the operating system implement the pthread application program to provide the interface which is given in the IEEE POSIX standard in this manner. So next move with creation and operation of threads. So when a process invokes the library function create underscore thread to create a new thread, the library function will create a TCB for the new thread and starts considering the new thread for scheduling. When the thread in the running state invokes a library function to synchronize its functioning with other threads, the library function performs scheduling and switches to another thread of the process. The kernel believes that the process is continuously in operation. If the thread library cannot find a ready thread in the process, it makes a block me system call. The kernel now blocks the whole process. This process will be unblocked when some event activates one of its threads, and it will resume the execution of the thread library function, which will perform scheduling and switch to execution of the newly activated thread. So this is the scheduling of user level threads. So here the thread library code is a part of each process. So it performs scheduling to select a thread and organizes its execution. So this operation is viewed as mapping of the TCB. You can see here we have TCBs and we have PCBs, right? So this is viewed as mapping of the TCB of the selected thread into the PCBs of the process. The thread library uses the information in the TCBs to decide which thread should operate at any time. So to dispatch the thread, the CPU state of the thread should become the CPU state of the process, and the process stack pointer should point to the threads stack. Coming to the advantages and disadvantages of this user level thread is the thread synchronization and scheduling is implemented by the thread library. So therefore, this arrangement avoids the overhead of a system call for synchronization between threads. So the thread switching, whereas the disadvantage is if a thread were to be blocked in a system call, the kernel would block its whole process. In effect, all threads of the process would get blocked until the cause of the blocking was removed.